Last time we looked at the different levels of programming languages, which start at the machine code containing individual CPU instructions and progress up to the high-level languages that we as programmers write. But the question now is, how does the computer process high-level languages source code into machine instructions? How can we take human-written code and convert it into individual CPU instructions? We do this with compilers and interpreters, which both accomplish the same goal but do it in slightly different ways. Let's start with compilers. A compiler analyzes the source code and produces the corresponding CPU instructions and saves it all in another file, called the object module. Compilers are specific to particular programming languages and particular CPUs, since depending on your programming language, you'll have different syntax that needs to be converted, and depending on your machine, that'll have to be translated to a specific machine language, since each machine language is dependent on the CPU that it runs on. If we had larger, more complex programs, they might not have only one source file, they might have multiple. Each of these separate source files are compiled into their own object modules, and then a linker comes in, which is a program that combines all of these object modules into one single executable program that gets saved in an executable file. So for any compiled program, once it gets written and is tested, the final executable program in the executable file is what gets distributed to the users. The users don't have and don't need access to the source code. They don't even need to have their own compiler. The executable program can run on its own with a particular operating system. That's why you might see some programs have options to download for Windows and to download for Mac, since they'll give you the right executable file for your operating system. An interpreter, on the other hand, works a little differently. An interpreter basically just goes through a high-level program, figures out what it needs to execute as instructions, and then just executes them. It doesn't generate any object modules and it doesn't save any executable code. It works on the spot, running programs immediately after converting them to machine code from the source code itself. Because of this, the users don't get sent an executable file since the executable file isn't even saved by the interpreter. Instead, they need access to the program's source code, which is often called the script in this case, and they also need access to an interpreter. The program has to be interpreted again and again, every single time it's run. To understand the difference between compilers and interpreters a little more easily, let's think about this. A compiler is like a CD or a digital recording, and an interpreter is like a live concert. You don't need Bruno Mars in front of you every time you want to listen to his album on Spotify because the digital recording's already there. Just like how when you use a compiler, you don't need the source code every time you want to run a program because you already have the executable. You do, however, need Bruno Mars at a live concert, just like how you need the source code every time you want to run an interpreted program. Usually, a programming language in particular is established as either a compiled language or an interpreted language, but at the end of the day, there's really no clear distinction. For example, C is a language that is usually compiled, but C interpreters do exist, we just don't use them very often. Java, on the other hand, is pretty unique because it uses both. It has this sort of mixed compiler plus interpreter approach, which we'll delve into with more detail next time.